TSRC webinar. My name is Andrew Tan, Sales and Market Development for TSRC. As the world's leading producer of styrene block copolymers, TSRC is dedicated to the development of high-value products. In recent years, it has expanded its product application categories to include medical, automotive, and high-end applications such as high flow, high transparency, and high oil filling ratio attributes. Today, we have TSRC speaker Mr. Anson Huang, who will be presenting TSRC-TPE polymers. Mr. Anson Huang, located in Taiwan, works for TSRC as a global marketing manager, covering new SBCs market development. With over 12 years experience in marketing, business development to sales role in TSRC, please welcome Mr. Anson Huang for his presentation on TPE polymer solutions.
Hi everyone, I'm Anson Huang from TSRC Taiwan. Today I would like to bring you the trip about TSRC innovative SEBS solutions. After going through the trip, you can learn more about TSRC SEBS product for target applications. In TSRC, I'm covering new SEBS market development, SEBS solutions for TPE compound and plastic modification, product and marketing strategy. With over 12 years of experience from marketing, business development to sales for adhesive, TPE compound, and plastic modification in TSRC. In today's trip, we are going to start from TSRC global presence, then introduce TSRC product portfolio and brand new SEBS product solution. At the final, we will wrap it up by two main applications, automotive and medical. TSRC is a global specialty chemical company from Taiwan. We are founded in 1973. This year, we are going to celebrate 50 years birthday. Major product is synthetic rubber and thermoplast elastomer, TPE. Globally, we have 9 production sites. In India and Southeast Asia, we allocate salespeople and distributor to serve customers. For elastomer product, we have SBS, SIS, SEBS, and TPE compound to fit your requirement. This presentation, we are focusing on SEBS product. TSRC have 2 brand names, Typo and Vector. Typo is for general SEBS, and Vector is for medical product series. SEBS product portfolio are ranging from high flow SEBS to high performance SEBS, from general SEBS to monoanhydrate SEBS and medical product series. Depends on the product properties. We also provide different product forms. They could satisfy your request in designing various product formulations to fit end product's requirements. Generally, we could see SEBS structure from 3 dimensions: molecular weight, styrene content, and vinyl content. Based on the product design, we could provide various product series with different performance. Next, we are going to introduce high flow oil-free and low hardness grades, SEBS 6040 and 8245D. 8245D is also a medical grade. SEBS 6014 is a high flow and low styrene SEBS with 18 polystyrene content. High flow design that it could combine strength and elasticity with the ability to process directly with or without additives. It could also compound with a variety of ingredients like polyolefin, polystyrene, and other elastomers to adjust the properties. Also, it is suitable for processing by casting, injection molding, or other processes requiring easy flow. Comparing to other low molecular weight grades, 6014 is softer and high flow. Softer means more degree of freedom to adjust the harness design. in the formulation with less oil migration risk. Higher flow means easy for processing by less energy consumption and carbon dioxide emission. Based on 6014 structural design, application could be covering from sporting, adhesive and sealant, and automotive which need high flow, oil-free, and elasticity property. In this page, we move to SEBS 8245D. 8245D is a high vinyl and low styrene SEBS. Based on the structural design, it could reach high flow, low hardness, and better compatibility with polyolefin. Because of high flow and low hardness, it has good processability without oil and is suitable for medical food content and show high transparency when compounded with polypropylene without oil migration risk. When compound with polypropylene, 8245D provides wide range adjustable hardness from 60D to 48. Because of 8245D high vinyl structural design, it can show excellent transparent, contributes to excellent compatibility with polypropylene. From this page, our trip arrived functionalized the Maleic anhydride graft SEBS 7126 and 7131. Maleic anhydride graft with SEBS could create polarity and functional group to improve the compatibility to polar materials. They are not only as impact modifier for engineering plastics, but also improving interfacial adhesion for injection overmolding. TSRC offers two types of melt flow rate Maleic anhydride graft SEBS. The melt flow rate of 7126 is from 50 to 30, and 7131 is from 2 to 15. This page shows you the mechanism of improving compatibility to engineering plastics. The main components of SEBS-based TPE compound is SEBS, polypropylene, and oil. Basically, it is a combination of non-polar material. Therefore, it could be overmolded to polypropylene directly. However, when you are going to overmold it with polar substrate, such as polyamide or ABS, you need to functionalize the SEBS as polar compatibilizer to enhance the peeling strength. This page, we decided to experiment by various composition percentage of Maleic anhydride graft SEBS to evaluate the impact strength of polyamide 6. From the chart, after added Maleic anhydride graft SEBS, we could see Maleic anhydride graft SEBS have good performance to increase impact strength. In this page, we are talking about how Maleic anhydride graft SEBS to compound for overmolding by different substrate. From this table, we can see 7126 and 7131 are suitable to both of polyamide and ABS overmolding. This chart is based on 10% dosage to evaluate the peeling strength. We can see peeling strength is improved after adding 7126 and 7131. Next, we are going to introduce another high vinyl SEBS grade, DP6240. DP6240 is a high vinyl SEBS with high flow. Compared to general SEBS, it could add less oil to achieve good flowability for processing and lower hardness to reduce the risk of oil migration. Also, 60 vinyl structure could contribute to better transparency when compounded with polypropylene. It is suitable for wire cable, plastic modification, and general compounding. Based on the same formulation, you can see the hardness of DP6240 is 12% lower than 6151. That means you could achieve the same hardness with less oil. It could be used in a form of application which are sensitive to oil migration. From this chart, you can see DP6240 has higher flow than general SEBS from low shear rate to high shear rate based on the spiral flow test and lower shear viscosity from capillary rheology chart. Higher flow means easy for processing with lower energy consumption and carbon dioxide emission. About the value proposition of DP6240 comparing to general SEBS, it could provide better flow, better transparency, and a lower hardness. Also, it shows smoother surface and less flow marks in injection and molded parts because of better flowability. About application of DP6240, it is suitable for following three types: better flowability for high flow injection molding components like thin wall, complex, and large part of injection molding. Softer and delicate touch like less oil to the same hardness. Low oil extrusion molding, such as wire cable and general extrusion molding. Next is ultra high molecular weight SEBS DP029. DP029 is based on 6159 to redesign styrene content for achieving better oil absorption and oil retention. Except the better oil absorption and oil retention, DP029's compression set is also better than 6151 because of ultra high molecular weight design. Longer EB block design contributes to better rebound resistance to 6151 and 6159. From this page, we designed two compound formulations including lower and higher oil dosage to compare oil absorption and oil bleeding. In this page, it shows neat SEBS was soaked oil in different time intervals to measure the capability of oil absorption. DP029 is capable of absorbing more oil than 6151 and 6159 due to longer EB block. This page, we can see the evaluation of oil bleeding out in low oil content and high oil content. In low oil content, the differences of oil bleeding is not obvious. In high oil content, DP029 has less oil bleeding, which means better oil retention with DP029 due to longer EB block. After going through TSRC's new developing product, we are going to next about application, and today we are going to introduce automotive and medical. The trend of material in automotive industry are eco-friendly to reduce waste, energy saving to reduce carbon dioxide emission, and low contamination to reduce fossil fuel consumption. For eco-friendly, we use more recyclable material to replace vulcanized rubber and thermoset plastics. For energy consumption, we use more light material like high-performance plastics to replace metal. For low contamination, electrical vehicle is chosen by global car makers. SEBS-based TPE compounds are commonly used in interior and exterior parts, from seating system, trim bumper, to airbag cover, interior skin and mats. For exterior parts, they need good heat and weather resistance. For interior parts, they need to pass VOC and haze test. As previously mentioned, SEBS 6014 is a high flow grade. Therefore, as impact modifier, it is suitable for polyolefin modification and it can be easily compounded because of its similar rheology. We can see shear viscosity under different shear rate on this chart. In this page, we first to evaluate the impact strength after 18 different impact modifiers. Basically, 6040 could provide excellent impact strength improvement by 20% in room temperature. From this chart, you can see 614 could greatly increase toughness of polypropylene from room temperature to minus 40 degrees C. Sealing system is another important application of SEBS. Static sealing systems such as twin seal requires to less compression set, but more aesthetic. SEBS is used more in this application. Dynamic sealing systems such as door seal, glass run is more requiring compression set and the durability in which TPB and EPDM deliver better performance than SEBS. However, certain compounders are competent to overcome the shortcoming by fine-tuning the formulation with the use of SEBS. 6159 is our major solution for sealing system. Owing to the large polystyrene block size, 6159 exhibits a higher softening point than 6151, better compression set at high temperature. From this table, you can see 6159 could provide superior compression set to 6151 from 70 degrees C, 100 degrees C to 120 degrees C. As previously mentioned, typo SEBS plays an important role to offer performance and eco-friendly. Comparing to TPB and EPDM, 6159 could provide low VOCs, better touch feeling, and lightweight. Next, we are going through vector SEBS for medical application. Comparing to other applications, medical product needs to follow more regulation. Compliance depends on their applications. Therefore, TSRC developed vector A series SEBS for medical application. They are not only ask for high quality standard, but also satisfy ISO 10995-5 and the USB Class 6. SEBS in medical is focusing on medical packaging like IV bag, polypropylene closure, syringe plunger tip, and the medical device such as surgical strap, IV tubing, and mask. For vector SEBS, we have high vinyl type 8245D for IV bag, IV tubing, and other oil-free applications, which require high transparency. 8101, 8103, 8104, and 8109 are normal vinyl grade for general compound and plastic modification, such as medical stopper, syringe, plunger tip, and the polypropylene closure. As previously mentioned, 8245D has good compatibility with polypropylene. Therefore, it could be compounded with polypropylene by various dosage to provide a range of harness for IV tubing, device tubing, oxygen, or CAPD tubing application. (8245D) is also suitable for polypropylene-based IV bag to provide excellent flexibility and a high degree of clarity. This page shows you an example for 3 layers co-extruded IV bag film. Generally, the thickness of 3 layers co-extruded IV bag film is 200 micrometer. Based on the purpose, it could add different dosages of 8245D to contribute to various functions of these 3 layers. Middle layer is the thickest to provide the flexible and transparent and need the most 8245D dosage around 30%. For outer layer and the inner layer, the suggested dosage is 10%, but it still depends on the formulation design. This is an example for plastic modification with various oil content to improve impact strength under different harness and TPE compounding, just for your reference. Overall, TSRC product design are surrounding with these 6 directions to satisfy market requirement on recyclable and sustainable material. We have launched the Vector SEBS A series for medical market, SEBS 6014 and 8245D with high flow, oil-free, and no harness for polypropylene modification to improve impact strength. SEBS 6159, DP6240, DP029 for high-performance applications such as automotive and other industry applications. Maleic anhydride graft SEBS 6126 and 6131 have good compatibility with engineering plastics to enhance impact strength and overmolding with polar substrate. Because market always needs new material for product development, TSRC will keep developing new environmental friendly products to fit their demand, especially under the trends of sustainability and recyclability for reducing impact to the earth. Thank you for joining today's trip of TSRC Innovative SEBS Solutions. If you have any questions, welcome to TSRC booth in PLASTINDIA at Hall 40. Booth number E7. We could have more discussion with you. Also, you could visit TSRC website to get more information about our product introduction. Thank you for your time. Bye-bye.